part of these courses. Okay, today I would like to talk about how to do programming in Matlab, how to implement the CNN using Matlab, which is actually very important for you to do your assignment, and for your informations, in your final exam also we have a few questions that ask you to write a Matlab code, but of course that the question is a little bit simple as compared to your assignment. Okay, your assignment is different because we do a project, and your final exam we just give you some, for example, architecture. Can you write the code for that architecture? So that is related to this CNN chapter. Okay, so okay, related regarding the MATLAB's code. Okay, the MATLAB code for CNN. In general, it can be implemented. Okay, CNN can be implemented in 4 different approach. Okay, one is you can use the existing CNN model, meaning that you can import the existing well-established CNN architecture like AlexNet, GoogleNet, and so on. You just take it and then you just implement it without training, meaning that you just use it because it's already trained by those who design that architecture. For example, AlexNet might be designed by Alex, so that's why you, after they have trained these architectures, then you just import, then you use it directly. Okay, that one I will, if we have time, then I will try to show you some example of this code. Okay, and then number 4 is another alternative. Okay, it is number 4 is a kind of advanced approach where actually, instead of you are using CNN for classification, then you can also use the well-established CNN. You modify it a little bit, then it will become the feature extractor or feature extraction from the image. Okay, let's say the input of that architecture's is image, and then you can from that CNN, existing CNN, doesn't matter is it AlexNet or GoogleNet, you can extract the feature, and this feature you train using other machine learning. Okay, but that is one of the I can consider as an advanced technique in design the CNN. But of course I will not explain the number 4, and then if we have time I will explain number 1 a little bit. But the one that I want to highlight more on these courses is number 2 and number 3, which is you are building your own CNN from scratch. And number 3, which is the best approach among these 4, which is by using the existing CNN, well-established CNN like AlexNet and GoogleNet, and then you modify or you a little bit on the architectures to tackle your problems. Okay, actually number 3 is related to your assignment, your mini project. We will use this approach to solve your project, which is using we will use the AlexNet and modify the architectures a little bit, just to make sure the AlexNet can classify whether the image is the image is containing the face mask or not. So we will use that. Okay, so let's go to number 2 first, which is building a CNN from scratch. Okay, for this one I will like to ask you to open this file. Okay, this I will upload this Matlab code in your e-learning. So before you learn about these video lectures, you need to download all the file first. Okay, including the dataset there. The dataset that we will use is digit dataset and MERS data there. And digit dataset is actually a minis dataset. Okay, it's a minis, is a sorry, okay, if you remember that this is a well-known minis dataset, Okay, actually this example we use this minis dataset. Okay, this one. Okay, now let's open the create simple deep learning from scratch, which is related to number 2 over here. Again, if you see the names there, of course the purpose is that instead of borrow others well established CNN architectures, the one that very important for you in these courses is that you have a capability to design your own CNN. So that's why number 2 is one of the important things in these courses. Okay, this is the code. Actually, this code is not I write from scratch. Okay, I take this code from existing Matlab example. So that's why one things that Matlab good is at is that instead of the programming language is easy, it also give you all the sources available online, and also the help is also, even if you don't have internet, if you are using the help from the Matlab, it help you a lot, because it not just give you the how to use the function, you also, the Matlab also give you some example which is very good. Okay, so okay, let me go back to the Google search first. Okay, so from Google search, okay, you just type this keyword Matlab CNN from scratch, and then you click this link, create simple deep learning network for classification. Okay, I take the example from this link or this website. Okay, this is the example, but I just do a little bit modification to the code, so then it's easy for me to run in my computer, because my computer is kind of heavy, so I need to make it the code quickly, so I simplify a little bit, but the content is almost similar. Okay, this is a minis dataset. Okay, there's the same thing. I just import all the things in one M file, then all the description there I convert it into comment in my code. Okay, that's why you see there's a comments there, the green font there. Okay, it's a comment that I copy from that site related. It represent the description of the every instruction there. Okay, okay, what you need to do is this, before I explain every section in this code, you just go to this section which is define network architecture. Okay, because that is the, if you talk about build or design the CNN from the scratch, actually this is the one, this is the one that represent that things. Okay, the rest is just the process of developing the whole system. Okay, but when we talk about designing the code from scratch, or you want to have your own customized CNN, then this is the architecture. So before we discuss about these architectures, let's go to this slide. Okay, just remember that when I said that in order for you to represent your network architectures, you can represent it in this form, which is in the pictures. So it's easy for you to, you know, to visualize the architecture or the physical appearance of your CNN. And the other way is you can also represent your CNN architecture in this text, which is understandable and readable by human, because it's using the human language. Of course, this one is important, okay, as compared to this one. This one is more important because if you manage to design your architecture in this human understandable language, and then it's easy for you to write the code for that architecture, because there's a lot of, like I said before, if you talk about the Matlab have their own way to design, to write the code that represent the architecture, which is, if you write in this way, it's easy for you to translate. And also, if you are, for example, if you are interested in applying CNN using Python, if are using easy library like Keras, okay, you can also, Keras is also using the same format, meaning that it's more understandable, and the arrangement is something like this. But again, like I mentioned before, there's no standard way to represent the architecture, because if you read a lot of research paper, some research have their own way to show the architecture. Some using this one, some might be using this kind of approach, and some might have their own kind of pictures of flow table and so on to represent the architecture. But the fundamental or the basic behind it that you need to know, for example, this one is not even I don't familiar with the standard way to write this description that represent the architecture of CNN, but you still can predict this is the input. Okay, the input, you have a RGB image with the size 227 times 227, and then the first layer, the second layer is convolutional operation. So they just put the number 1 because later you have convolution number 2 and number 3 and so on, and then you have 96 numbers of 11 times 11 filter, and then you have a stride equal to 4 and no padding because padding equals 0. Okay, so means that you know the item that we have discussed before, what is convolution, what is stride, what is padding, and then you have a pulling and so on. Okay, but for this class, let me standardize this architecture because we don't have any standard architecture, but of course in this class we need to have a standard architecture, because later when you, for example, if I ask something in final exam, then easy for you to interpret. Instead of using this kind of architecture, let us have something like this, but it's more easy to understand. Of course, it's not so much different from this one, but it still can make you easy for you to translate from the description into the Matlab code, so it's easy for you. So let's give you some examples there. Okay, let's make this one as an example, which is this code. Okay, again, this is the architectures that can actually, this one is come from this description. Okay, this description. Of course, it's not this description. That one is another CNN. But if you, as a deep learning designer, then you might have this description first. Once you understand the architecture in this description, then you need to write the code in this way. Okay, so you can see that it's not so much difference there. Okay, from this part, which is you layer by layer, you describe layer by layer, and this one also describe layer by layer. As you can see that layers there. Okay, you see the Matlab code cell, layers is equal to open bracket and close bracket is here. So that means you can also write in horizontal directions there, from that direction. Okay, you write everything here in that direction, but of course it's very difficult for you to understand the architecture. That's why, in order for you to make sure that you understand the architecture, so that's why the arrangement like this. You are right, the component of this layers that the matrix layers there, you actually is a horizontal direction, but because you want to make sure that you understand the architectures very well, so that's why you write one by one, meaning that the first item is this one, and then I put a space there to make sure that you know this is the second layer, and then this is third layer, this is fourth layer, fifth layer, and then and so on. Okay, so of course you can also, like I said, you can also write something like this. Okay, because it is actually it is a matrix, one-dimensional matrix. Okay, you can write like this. Okay, you can write like this straight into a horizontal direction, but of course it's very difficult for you to trace the architecture, so that's why we write in this way. Okay, so then you will see that this is the first layer, this is the second layer. Okay, before we translate that, okay, now I want to give you some example. We do some reverse engineer, meaning that this is the code. Okay, how do we translate this one or reverse engineer back into the description in text related, which is represent these architectures. Okay, I just give you some examples there. Okay, you can write in this way. Okay, remember that this is standard way to describe the CNN architectures in this class. Okay, we need to have some standard way, otherwise you will have your own standard, because there's no standard in practical. There's no standard. Some people write in many way of their own, but everybody understand the description, because you need to have a skill in, I know you need to have a knowledge in to know what is stride, what is padding, what is convolution, so then you know how to translate the standard their description there. Okay, as you can see that why I put a space there, because it represent each and every layer. Okay, the first layer is input layers there, so that's why in my architectures I put this. Okay, this is my standard way, so means that you need to use the same standard for your you need to use the same standard for these courses. Okay, because I don't want to have many variation of standard, so you just put input. Okay, this number represent the layer number 1, layer number 2, layer number 3. Okay, layer number 1, which is related to this one, you just put input, and then you put the size of the input. So the size of the input is 28 times 28 times 1, so meaning that this is a grayscale image. Okay, because you have depth equal to 1 with the size 28 times 28. And then second layer, which is related to this one, it's a convolutional process. I put it convolutional number 1 because this is the first convolution for this CNN. And then okay, and then you can see that the number of filter used in this convolutional process is 8. You have 8 number of filter because this is 8. Okay, and then 8. Okay, you can search for this one in Matlab. Then you will see that this is the size of the filter. If you put 3, means that a 3 times 3 filter. This one is represent number of filter. If you put 8, so means that in this convolutional operation you have 8 number of filter, and the filter size is 3 times 3. And of course, since you don't mention this, you don't mention the number of stride there. By default, the stride equal to 1. Okay, so when I try to explain this this process, you are reverse engineer from this one and this one, At the same time, I also explain everything happen inside here. Okay, so make sure that you um, you alert on that. Okay, means that you take focus on that. Okay, convolutional convolutional two-dimensional layer is a convolutional operation, and then the argument or the input for this function, if you put the first number, it's represent the size of the filter, and this is the number of the filter. So that's why if I write over here convolution number 1, 8 3 times 3 filter, meaning I have 8 number of filter with the size of 3 times 3 filters. And then since there's no information about the stride, so by default, if you don't mention stride here, then the stride is equal to 1. And because you in this line there, you mention the paddings there, padding is equal to, padding is set into same. So what is the meaning by that is that this convolutional layer, if you set padding equal to same, meaning that you want to do the convolutional process where the output size must be similar to the input size. So doesn't matter you put the filter 3 times 3, 5 times 5 and so on, this function will automatically try to take this into account before they decide how many number of padding. Means that, let's say the size of filter is 3 times 3, then if you set padding equal to same, then it will put a padding equal to 1. If your filter is 5 times 5 and then you put padding equal to same, meaning that the number of padding equal to 2. Okay, remember the slide there, the slide talk about the padding. Okay, let's go back to the slide related to padding. Okay, this slide. Okay, you remember that when the filter size is equal 3 or 3 times 3, then the zero padding equal to 1. So if the filter size is 5 times 5, the zero padding is equal to 2. If the filter size is 7 times 7, the zero padding is equal to 3. That is to make sure that if you want to make sure that the output volume or the output matrix size is similar to the input matrix size. Okay, so like I said before, in general it's very difficult to see people use padding for other purpose, because I see that in general padding is always have been used to maintain the size of the output. Okay, even you can have you can have a 5 times 5 filter and then you put a zero padding equal to 1. Of course, if you do that, it will the image, the output matrix have been shrink. Okay, means the output matrix is smaller than the input matrix. But of course we don't do that, because there's a lot of things can be done to reduce the size of a matrix. For example, you have a maximum pooling, you can reduce the matrix size, and then you can also you apply no padding. By applying convolution without with no padding, you also can shrink the size. So that is, there's a many way to reduce the size. But when you apply padding, normally they will use it for maintain the size of the matrix, meaning the matrix output matrix size should is similar to the input's matrix size. So you want to maintain the size. So that's why in Matlab here, instead of that's why they just fix there by set there. If you want to apply padding, and then you have a special function there, if you set a padding equal to the same, then it will consider the size of your filters there. If your filter is 3 times 3, means that they put a zero padding with 1. If you apply the size of filter 5 times 5, the zero padding is 2 automatically. So just using this word padding same, it will automatically maintain the output size matrix similar to the input size matrix. Okay, now back to this, how to reverse engineer back from this coding into these architectures. So you can see that the convolutional layer number 1, so we have this filter, and then stride equal to 1, because by default, because if you don't mention the stride is equal to 1. And then because you have padding, I just put there padding, meaning that if I put the paddings, meaning the padding is same, means that the padding, the size of the output should similar to the output to the input by applying the padding. Okay, or you can also write in this way, padding equal to same. Okay, if you want, but because normally padding is used for make sure the same size, so that's why I use paddings. Okay, but you can also put that padding equal to same. And then the third layer, oops, sorry, before I discuss this one again, as you can see here, this 3 line represent this layer. Again, like what we have discussed before, convolutional layer is not only involve the convolutional operation, but is also involved with activation function. So that's why this one is the convolutional operation and this one is activation function, which is we are using the ReLU activation function. Okay, remember one of the activation function is called ReLU, so this is why we are using ReLU activation function. So and how about this line, batch normalization? Okay, that's why we discussed about batch normalization before. Like I said, batch normalization in Matlab, okay, if you are doing CNN in Matlab, batch normalization is always must be put after the convolutional operation. Okay, like in video in the previous lecture, I always remind you that batch normalization can be applied either after the conversion operation or after the activation function, which is in this position. Okay, but in Matlab, they already fix batch normalization must always here, but in my slide not there, in the previous lecture I said it can also be put here, but that is if, let's say, if you want to design this CNN in Python using Keras, a Keras library, then you can do that. But in Matlab, I find out that most of the people who write Matlab code in CNN, they always use the batch normalization operation after the convolutional operation. Okay, but like I said, if you write the CNN in Python and so on, you can have the batch normalization in this position. Okay, so as you can see, that's why this 3 component is compulsory for you to represent the convolutional layers, which is this one. Okay, meaning that this, even this spec, you just capture the information from here, but if you talk about the convolutional operation, you must not forget this 2 line. Okay, because this one is just represent the convolutional operation. Of course, again, convolutional layer involve not only convolutional operation, you also need the activation function as well as normalization to avoid the imbalance scale among features. Okay, and then that's why I put the space there to present this is the first layer, this is the second layer. Now the third layer is pooling. So pooling layers, of course, pooling layer don't most of the time don't involve with padding, so that's why we don't have paddings there, but we have a stride there. So you just put maximum pooling number 1, because this is first maximum pooling. The filter size is 2 times 2. Of course, we don't have number of filter in pooling. The number of filter can also exist only in the convolutional layers. So that's why you put 2 times 2 filter with stride equal to 2. Then you can continue to do this one. Okay, this one is the the second convolution operation. Layer number 4 is second convolution layer, then double dot. Now the description is you have a 16 filter with the size 3 times 3. And then how about the stride? Stride does not mention, then meaning that stride equal to 1. And then how about padding? So padding is, there's a paddings there. Okay, you just put paddings. I think it's better for you to just put padding. Okay, so paddings means that paddings means the padding is equal to same. And then how about the fifth layer? Fifth layer is just max pool. So max pool number 2, because that is number 2, double dot. And then you have 2 times 2 filter again, and then you have stride equal to 2. Okay, and then this number 6 filter is a convolutional, which is convolutional number 3. And then you have how many filters? 32, with the size of 3 times 3 filters. And then how about the stride? Still the stride is equal to 1. And then you have padding. Okay, now layers number 7. Okay, for this one is already fully connected. You just write a fully connected. Fully connected. And then you just put 10 neurons, because fully connected with 10 neurons. And then you finish with this softmax. So, yep, you finish with the softmax. Okay, there's a bit corrections there. Normally, because this one is the last layer, normally fully connected and softmax should be together. So it should be that way. Okay, means that these 3 represent one layer. So meaning that let's say the full connected layer is because as you can see that this softmax layers is the activation function of this fully connected layer, meaning that at the end of this architecture, because the classes, you have 10 classes, because later this code is related to minis, where you want to classify given the image of handwritten image of from 0 to 9. So you want to design the CNN that capable to classify these handwritten numbers into to classifies into 10 classes, which is 0, 1, 2, 3, 4 up into 9. So that's why the last layer always end with 10, because represent the 10 classes. So for this last layer, normally you can directly write something like this, okay, which is the layers number 7, just put it as softmax. Okay, softmax. So as softmax. Okay, softmax with 10 neurons or 10, something like that. Okay, but that does not mean as you can see that that is only happen at the last layers. Let's say for example this architecture have something in the middles there, in between that or the second last layer, you have a fully connected like this. Fully connected means that you have another fully connected before the architecture is end. For example, you use a fully connected 100 neuron. So for that case, then you need to have layers number 7, which is fully connected. fully connected, and then you put 100 neurons. Okay, so if fully connected layers is independently, meaning that when I say independence, meaning it's happened within this layer, except the last layer, then it will become one single layer at this part, which is fully connected. But if your fully connected layer represent the last layers, then you just call it as a last layer, which is softmax, because we are using a softmax activation function at the last part, and then the final neuron is equal to 10, because the output here is you have a 10 classes. Okay, you don't have to write the classification layer, because this layer actually is represented by this. Okay, I just give you some examples there. Let's say you have another fully connected layer. I'm sorry, you can put it as a fully connected number 1. One fully connected layer which is not the last layer, means that you have a other fully connected layer before the last fully connected layer, then you can put this independently, then it's become a layer. Okay, because in general, when you talk about classification, it always end up with the numbers which is represent the output, the final output. Is it, if you talk about 2 classes, then you have two there. Now because we talk about the to classify image and classify it into 10 classes from 0 to 9, then that's why we have 10 there, and we don't have these layers. For this example, we don't have that layer in this example, so that's why we have this kind of layers. So that's why in these architectures we only have 7 layers. Okay, we delete that one. Later we'll see another examples of that. I just want to show you actually in general you need to write this one first, then you translate into this code. But this one we do some reverse engineer. We have the code, we try to reverse engineer and try to do the description related to the architecture description in the text there. So make sure this is the standard way that you familiar with it. So later we will have that one again for the exercise.